start the server once, but the rest of the things you will use again and again in a lot of places. But this function, the create server function, you will use it only in a single place. Or if you are using express.js, which we will be, there is a better way to do this. So right now I'm going to teach you how to start a server. Okay, so http has a method for it. You can say const server is equal to http dot create server. And what will this do? This will create a server in whatever port you wanted to create. So this is an anonymous function, lambda expression. We have talked about this. Inside the create server will send the request and response. So request and response are actually going to be arguments to request and response. We talked about what request and response is. Request comes from the front end to collect some data, and the response is given to the front end by the back end after collecting some data from the server. The We'll talk about this. Okay, let me show you. And the response, I told you, right, it is something given to the front end by the back end. So there are some methods inside response. We'll talk about the methods inside request and the method inside response. So response dot, the simplest thing is right. We'll actually be using JSON a lot, but still it is important to know, right? Welcome to my home page or something. All right, and we'll also end the response. If you are opening a response, let us end it also, because there is no middleware right now. What I've actually done is, inside the variable server, I have created a server using the HTTP method, and that server will send a response saying welcome to my homepage. That's it, nothing complicated. So I have to call this variable and run this response or get this response for it to do. And server dot listen. Now listen is another function which is going to help you see all of this in the front end in your local system. Now listen takes a lot of arguments, but the most important argument of all is the port number. Okay, it can take the port number, it can take some function it has to run if the connection is successful or something like that, all these things. So for port, I'll say 5000. Okay, we'll also talk about what ports are. So this is a simple code. Now we'll see what happens if I run it. I'm going to say npm start, or actually I'm going to say node module testing. And what happens is, nothing actually happens, nothing is printed inside the console or something, but it is actually inside a loop. It is not getting again to read another command. The program is even right now running, because we have started a server. To end this program, to end this JavaScript code, I have to end the server also. How do I end the server? We use control C, copy command, control C. To start the thing, to run the code, we say node modules testing. So what is going to happen now? We can actually go to this port number. Now what is a port? We talked about IP in the previous session, right? What is an IP? IP is going to specifically identify your unique device inside the internet has lot of connected computers connected to it, and you have to identify each and every connected device individually, uniquely, so that you can send data to that easily. If you don't have an address, right, you cannot get letter. So only when you have an address you can get a letter to that address. So even inside computer, inside the internet, something works like that. If you don't have an IP, you cannot transfer data. That is the protocol. So HTTP works after IP. If you have an IP, you can run HTTP. Then when HTTP is run, right, the device is going to get the data, but the data has to reach a specific application. Now I can open multiple applications inside my browser, right? I have opened Zoom here, I have opened Mayam here, I have opened one tab here, and all of this is working separately. All of them are connected to the internet, all of them are displaying different data, all of them are going to be using the HTTP module. But how does it identify the data I'm getting from the internet? For Zoom is specifically for this website. For Mayam, it is specifically for this website. Now you will be able to do that because of port. Now port is, when you normally think about port, right, what do you think about? USB port, HDMI port, SD card port, all these things, right? Your phone has USB-C or lightning cable. What does those ports do? It will help you charge or it will help you transfer data. Now this port I am referring to, you know, this port I am referring to is a virtual port that is built on your system. It is not a physical port where you can connect cables. It is a virtual port that automatically is generated inside your system kernel, which helps IP transfer of data through HTTP. Now, if you open your command prompt and run netstart and you will see all the ports that are running inside your system. It can start from zero to a lot of things. Now we'll be using the 5000 port. The thing has already started, it is running. That is why it is showing me 5000 port here. Now the IP address is the first four digits. After that, after the IP helps in transfer of data from the internet, TCP is a transfer control protocol that happens inside your local system. Since your local system has multiple ports, the data from the IP will be decided by the TCP to which port this data must go to. So right now inside the 5000 port, something is being listened. So we'll go to this 5000 port. You can copy this address. I think it will work like this. Let us try. Okay. If you run it like this, right, I don't think it is going to work. But what you can say is local host 5000. And what will it do? It will display. Now this server I have started, okay, the create server, the program that is running inside my local system. It is not in the internet. You can see 000, right? It is not due to IP. It is local inside my CPU, inside my hardware, all these things. Now, this is not how you'll do it in a real world scenario. Okay, if you are created an application, you will host your application in a more powerful server, not on a laptop or some simple thing. So, but this is for development. When you develop, right, this is how you develop the application. See, I am hosting it inside my laptop and I'm able to look at the data or the response that is coming. Now you can press F12 to open this developer menu. We have talked about this, or you can press inspect to open it. What it will do is you can go here, check for the network, reload it. Right. It will show you what amount of time has taken for all the requests to happen. We talked about this. There is a route it takes for the internet. We can't just directly access all the data. We have to take a route, or we in the sense the data that we requested, or the request itself that we send, takes a specific route to the destination where the data we need is present, and from there the data again takes a route back to us, and all of these happen in certain amount of time, some 1000 milliseconds or 2000 milliseconds, it depends on it. Now you can see here in the first 7 milliseconds we are getting the response for this request URL. Now we talked about request and responses. A request comes from the user. Now if I did not give the search for this URL, I won't be able to see the data present inside that server. So I have to search for specific URLs to access specific data. If instead of dashboard, right, if I had given course and content or submissions, it would go into those things. If I change the URL, the data that the thing is accessing from the server, which comes as a response, is going to be different. In our case, we are sending a response, welcome to my homepage. So that is why it is printing that stuff inside here. Okay. So this is the most basic way you can implement HTTP. So we look at we've talked about the first thing, right? Request URL. So that itself, you can imagine the back end to be the communication medium. Okay. And what it does is you have the, let us say, the server. Now server has the data, but you should not give access to server data directly to your users, because that will create problem, and that will create vulnerabilities, all these things. Because if everyone can access all the data directly, right, anyone can see anything. That is why backend exists, for authentication and constricting what data is seen by the user or the client. So the user always gives the request to the backend. And we looked at how some business logic will happen, and the backend will send a response back to the front end. And this is possible because the business logic knows through the request what kind of data it needs, and that specific data it accesses from the server. Okay. This is how a full stack application actually works. You can have multiple servers, multiple business logic, microservices, run them inside a container, all these things. But this is the most simplest setup. This is the most basic setup. According to this only, all full stack architecture is built upon. Okay. And what we are mimicking here is we are sending this request URL. We are searching this request, and the request contains certain data. So the request is going to be your label. What is the label? When you send some parcel, right, or Amazon sends some parcel, they will have a label saying these are the contents, something something. These are where it should go, and these are who it is coming from, to, from, and the type of data, type of the content inside the parcel. And this is a request. Okay. And the response in turn contains the actual data. The response in turn contains the actual data that is. I am not able to. So yeah, the response is what comes from the back end through the server, or comes through the back end from the server, which actually contains the data necessary for the user or the client. And the client is submitting a form, that is what we call a request. It will contain what kind of data it wants, and it will tell it through the request url, what the request method, what type of data manipulation it wants to do. We talked about the CRUD operations, right? So each CRUD operation has a certain method that it can do, or a certain method through which you can do the CRUD operations. So not only inside Node, okay, anywhere inside programming, to create new data, it is called posting. Post. To read existing data, it is called get. To update existing data, there are two methods: put and patch. And for deleting, the method is delete. Okay. So these are going to be your request methods. In our case, we are reading a response from the backend. So we are actually using get method. We'll talk about how you can add data to the server using post, all these things, how you can do CRUD operations. Once I teach you how you can start databases. So, until now we have looked at create server, listen, okay, and the other two things, request and response. So inside a request, there are a lot of things you can do. You can say url, method. There is also parameters that the user can send. There is also body. The body comes, you know look at this example, okay. When the user is requesting data from the server, he will have the label, what kind of data he's requesting, trying to read, what kind of data, or where it has to come, and from where it has to go, right? All these things. But if he's trying to add data to the server, he will also have some amount of data inside the request itself, right? So this is called the request body. We'll talk about all this and implement all of this in code, okay? So don't worry about it now. Request URL, method, params, and body. Response also has things. We already looked at right end. There's also something called right head. Inside a request or inside response, you can also send a status. We'll also talk about status. What is status? This is the status. Here, the status code is 200. We'll talk about all of this, okay? 200 means okay, success. 400 meaning error. There are things, status codes, HTTP things. I'll teach you those things. So, status, apart from status, what else is there? Yeah, send. You can also send JSON or other things. So what I'll do is we'll look at some implementations of these things. I will try to console.log request.method. So if I reload the page, okay, inside the console, or actually inside the terminal, I will be getting get, because I am trying to reload it, right? Every time I reload or trying to read, it will print new get here. Let me reload a bunch of times and show you. So you can see here the number of get has increased, because every time I'm reloading, I'm hitting this, I'm sending a request to the server or to the backend that we are creating right now, that I need. Right now there's no data, but we are still sending a response with some data. Usually you will get data from some database and send the response back. In our case, we are hard coding the data itself, meaning welcome to homepage. There are a lot of ways you can do this. It does not have to be text. Okay, you can also return HTML, you can also return JSON. It depends upon the kind of thing, data you are trying to transfer or trying to show to the user. Now, request URL, the request URL is actually something we can check. Okay, let us try to check the request URL. No, this is not the request URL actually. you know there is another way to actually check for request. Okay, don't do it like that. You can see here, every time the URL changes, the data displayed is also changing, because that is how we send new data and try to render those things inside the website. Don't worry about the front end. Okay, this looks ugly now, but once you learn HTML and CSS, you can style whatever things you want. But right now, worry about the data things. We'll try to send different data for different URL. How do you do that? You can check for the request URL, and I'll teach you something. Home. This is home. Okay, I'll send response dot write home page. If about. So we'll also say response dot end. Now this response dot end that I'm writing at last is like an else statement. Okay, the response will end if I am not searching the URL is not home. Now when I say home, this is the URL we are searching. Okay, but if you look closely inside the network, you will notice something. The request URL Actually, the server, you're not running the program, the server is ended. But if you look at the URL, right, even though we are searching 5000, it has 5000 forward slash. That is because that is the separator, URL separator, and also that is how the parameter and the URL is read. So if I had a slash, right, that is going to be home. If you look at something, right, this will be home. Mayam, only mayam.com will be the home. Everything that comes after it is going into some specific thing and some specific data. If I search for only mayam.com, right, it will show me the home. So that is how data is also, separated. Now let us run this code and see what actually happens. So when I search for this, right, you can see home page wrong URL entered because I have ended the request only here. Let us end it here itself. I told you, if you don't end the response, it does not actually end. And there is something now, I'm not able to hot reload. Okay, every time I make changes to the code, it won't get visible here. What you should do is you have to terminate the server and start it again for changes to be done inside the code. Since the response is ending, the code is also ending. It is throwing an error saying something, the home page is being visited. Now let us go look at the about. Let me start the server again. Instead of saying this, I'll say about. So when I say about, it is showing me developing a website. Let me start the server again. If I go to contact, it is CONTACT. Okay, if I go to not contact, see, that is why it is saying wrong URL enter. If I say contact, right, it will it will show the proper details, and it is all coming through the response. I am sending this response when this URL is hit. Okay, but this is not the way you will be doing it. This, there is a better way to do this through Express as a middleware. I'll teach you about that. So I hope you guys are clear until now how to do all of this. We have actually looked at server, create server, listen, request URL, method, response, write, and end. So we look at all the other things now. Okay. So if you guys have any doubts until now, you can ask me. Okay. So the CRUD operations will be working with HTTP more once we actually start developing the project. Okay, but we'll also be using Express as a middleware for HTTP Node.js. So we'll also be looking at Express, but right now what we'll be doing is be looking at some node concepts which makes node asynchronous and how you can use asynchronous methods and all these things. So we'll look at Event loops. And async patterns and strings. All right. So I told you we saw how this thing worked, right? When we search for specific URL, specific response was sent. Now we were able to do all of this easily because I am the only one using this website right now. I'm the only one using this server right now. And since my laptop is okay thing, it is working properly. But if millions of users were using this website right now, my laptop cannot handle that much amount of request, because the front end exists and the user interacts with the front end to send requests, right? That is how requests are sent. If you decide to now take for instance some Instagram, right? If you decide to, let's say, post a photo, what you will do, you will upload the photo, you will try to give some caption, you will add all the details, this will all become request body. Okay. And you will hit or click some button, and that button will try to send this request to the backend or the business logic. And what will happen inside the business logic? Inside the business logic, it is actually going to trying to see if the data, normally this is the pipeline. It will error check whether for trying to post you have given all the necessary details, form validation. If you have given all the details and all the details are of proper format, then what it will do, it will take all the details. Once it has checked it is of all proper format, it will add it to the server in the correct database. So if millions of users were doing that in the exact same time, right, what will happen? There will be millions of requests. So the backend where it is hosted must be able to handle all of this. So bigger systems are used now to handle all of this, right? Since we are using JavaScript, which is single threaded, which can read only one command at a time or one request at a time, until the one user gets his request finished through some milliseconds, some 700 milliseconds, right? And until the first user, 700 milliseconds, like zero point 0.7 seconds for his request to finish. The other 7 million users has to wait zero point 0.7 milliseconds, or else it won't work. If since JavaScript is single threaded, okay, and synchronous. Now if you calculate it for a million users, right, one user it takes zero point 0.7 seconds. For the millionth user, it would take 0.7 into 9999999. That would be almost some 10 minutes or something. So imagine if Instagram took 10 minutes to post your photos, would it be a good user experience? No, right? So to make request run asynchronously or parallelly, to run multiple requests or to run requests from multiple users at the same time, node was introduced, making JavaScript asynchronous. All right. So that is what this async pattern means. There are a lot of ways in which you can use syntax to make something asynchronous or handle something that is already asynchronous. What are the things that will become asynchronous? Whenever there's an actual connection happening inside the internet through network, there will always be a small amount of delay, a millisecond delay. and you should be able to handle this millisecond delay. Now if the millisecond delay rate, if it is not handled properly, now since it is right now it is like this, I am able to see the data, it is working, the code is working properly. But if the data is not visible, right, what will happen? It will show me a 404 error, a status of 404, and the request won't be handled properly. So that is where asynchronous comes in. So the difference between asynchronous and synchronous is, think about this. When a program is running right now, right, all the blocks of codes, all the lines of codes is run one after the other in JavaScript because it is single threaded. It can read only a single line of code at a single time. It is not compiling code, it is interpreting code line by line. Okay. This is called synchronicity. But this makes Java, actually this is not a entirely drawback thing. Okay, even though it makes things slow, it is type safe, meaning if some error was to happen at line 2, right, the program will stop, since line 3 won't work because line 3 is dependent on line 2, right? But some other programming languages are not type safe, like JavaScript and all these things. Not JavaScript, like Python and all these things, because they can compile code generally and they don't depend on the previous lines. But JavaScript is not like that. So to make things asynchronous, or to make JavaScript run multiple lines of codes parallelly, at the same time this line of code is running, this line of code can run, and this line of code can run, and this line of code can run. How is that possible, and how does Node make it possible? Now in this time, if each command takes, let us say for our understanding, 1 second, right, for all four commands to run, first command is running 1 second, second command is running another 1 second, third command is running another 1 second, fourth command is running another 1 second, 4 seconds to run this program. But in asynchronous programming, each command takes 1 second to run, but since all of them are running concurrently, are running parallelly, it only takes 1 second to run all four commands. So this is the benefit of asynchronicity, even though it is not type safe. Meaning, if this line of code is wrong, right, and at the same time the third and the fourth line are being computed, are being processed, if the data is dependent, right, then if this line throws out an error, all the other things are also going to throw out an error. Now that is why we need async patterns and how to maintain async patterns. Okay, so async patterns are some syntax that you can use to maintain thread safe and error catch or error handle. We'll talk about that, but before that we'll talk about loops or event loops. Now this event loops is present only because you are working with Node. If you have not installed Node, right, you won't be able to work with event loops. I mean, the event loop concept won't work for JavaScript. You can run JavaScript normally, but you won't be able to run it parallelly and things like that. So what does the event loop actually do? Now this is your entire, let's say, system or hardware or something, server. Let us say this is the database. Here are the users. There are millions of users. So millions of requests every single second. what happens is the request comes through some front end in the form of request. Since there are millions of requests, first there's a request queue built, and all requests are set to some priority index, meaning, by default all commands will have some 5 or 10. Okay, meaning they are not of high priority or of low priority, default priority, but you can change the priority index based on what you want, how you want your application to behave. But what actually happens is this backend logic is actually running inside some server. All right, and that server will have some OS installed on top of it, and that OS will have the system kernel, and the system kernel is going to decide the order and how the commands are going to be processed. How does it decide? It decides based on the hardware of your system which is being hosted. Uh, you know, your I told you, we have talked about this. All computers will have processing, memory, and things. The thing about processing is processing inside your mobile phone or computer or the processor is actually referred to as CPU, Central Processing Unit. Okay, there is also something called GPU, called Graphical Processing Unit, but you don't have to worry about that. Now, the Central Processing Unit, what it does is it has cores. Now, you must have heard about this dual core processor, quad core processor, octa core processor, meaning the number of cores. It can be 2, 4, 8, 16, all these things. Okay. Before 2017 or 2018, for every core count, for each core there will be two threads. If it was a dual core processor, two core processor, there will be four threads. If it was a quad core processor, four core processor, it will have 8 threads. If it was an octa core processor, it will have 16 threads. What does that mean? Threads are the most basic computational gates, meaning each command will use a single thread to compute the command in a single unit of time. That unit of time can be millisecond, nanosecond, it depends upon the task command. Okay, so if a 8 core CPU has 16 threads, that means it can run 16 commands parallelly. Now, the actual real world application, even the Zoom application, is running, the backend is running on some server which will have multiple CPUs. Okay, I told you a computer will have processing or CPU, but a computer can have more CPUs, more than one CPUs. There are lot of ways to make a computer powerful. A single CPU with a lot of core count, or lot of CPUs with smaller core count. The core count and the thread count is actually important, but there's a real good area which you should not cross. Okay, the amount of, you don't have to worry about hardware architecture, all of these things. Let us worry about software. Okay, so if it is a 16 thread processor, right, then you can run 16 commands parallelly. So a real world server will have multiple cores, hundreds of cores, and if each of those cores were 16 cores, right, it will have 32 threads. If it has hundreds of cores, the hundreds of CPUs, then it would mean it would have some 32 3200 threads running parallelly, 3200 commands parallelly, and they will have multiple servers like that. So they are actually able to handle millions of requests at the same time. Okay, like Instagram, Facebook. This is how the actual server is built. So the system kernel offloads the IO operation to something called the event loop. IO operation means input output operation. System kernel is part of the OS. Whatever OS, servers usually don't use Windows. Okay, Windows is a heavy operating system. Heavy meaning user, a normal user who's not even to- able to code or all these things will be able to use it properly because it has graphical user interface. I'm able to click buttons, all these things, select all these things. But server OS are lightweight OSs like Linux, Ubuntu, Fedora, all those things. They won't have lot of these things. Actually, there is a Linux OS called Arch, and the only thing that OS has is a command prompt. All of the things that you do inside the command prompt. So you won't see buttons, all these things. You, inside an operating system, when you think about it, right, when you click a button inside the background, some command is running. Instead of having these buttons and things, Arch Linux directly operates from the command prompt, where you can directly type the command so that you don't have to click buttons. You can directly run the function you want to run. So OSs, right? System kernel. All OSs will have system kernel, which will have access to hardware so that it can run or give the commands properly to the hardware for it to process. Now, Node directly offloads the IO operation, the code we are writing. It will directly offload all the code we are writing to the system kernel, and it creates something called the event loop. And what will this event loop do? This event loop, basically, if it is 16 threads, right, you know even though Instagram has these large amounts of server, and even though it can process millions of commands, the amount of users inside Instagram is not in millions. Okay, it is in billions. So even though the hardware is capable and powerful, it still is not able to fully handle it. So what event loop does is, if there is 16 threads, then it runs the 16, it takes the first 16 commands, runs it, sends the request, and makes all the other commands wait a few milliseconds. So it becomes asynchronous. Okay, it is not running synced. It not everything is running line by line or one after the other and things like that. Some things are being put on hold. It does not matter if you and your friend are both trying to post inside your Instagram, right? It does not matter who clicked the button first. It depends upon the system kernel. The system kernel is going to decide whose request to complete first based on different parameters and factors. Okay, that will depend upon the company and how they handle their users. It can depend upon who click the button first. It can also depend upon your internet speed. It can also depend upon a million other things. Okay, but system kernel is ultimately what is going to decide which command is going to run first, which command is going to be put on hold. And this is called the event loop, and it does it non-blockingly, meaning the input and output. In the case input and output, I say it, the input and output is the request and response. Request comes from the user, response goes to the user. So input output, and this input and output is going to happen non-blockingly. Even though I say non-blocking, I told you, right, it puts on hold. It feels like it is non-blocking because it happens only in milliseconds and nanoseconds. We won't be able to perceive it, the delay, but it still exists. And since it is happening so smoothly, we are calling it non-blocking IO operation. And it is happening because Node is having this event loops concept. This diagram is a little bit confusing. You can go to the internet and look for ev- event loops node.js. There will be better diagrams here. Look at this diagram. I also talked about V8, right? The engine. In our case, node is going to be our engine, and the OS will offload everything to the system kernel. The event queue will be built. The threads, worker threads, I told you, right? Threads is what is going to do the thing, and the event loop is going to make the operation non-blocking. Here they have said blocking for some reason, but it is actually non-blocking. Okay, non-blocking means the commands in the event queue are not going to be blocked. They are going to be running constantly. Maybe first thread pool database. The best example would be, I think this is the best example. So that is what it basically does. Okay, and that is how it makes things asynchronous. You can see here, right? It is asynchronous, and there's also something called libuv. Libuv is actually a library that can do logical operations. Okay, we've we talked about all the programming languages, right? All programming languages use this libuv for some amount. Libuv is a library which has lot of methods. Okay, all programming languages borrow some methods from libuv to handle these things. Libuv is actually assembly language. Okay, assembly language is something that directly translates to binary code. It is the fastest programming language. Assembly language, you know when you write javascript or java or anything, it first translates into assembly language so that your os can understand that. So once the javascript interprets everything to assembly and the os can understand it, and it goes into the event queue, libu library can be used to handle methods. Okay, that is why it is that here. You don't have to know that. If you understood what I just said, it is good for you. So let me give some words and we'll go into the actual code. Event loops, what it does, it performs non-blocking IO operations. JavaScript is single threaded, and what? Synchronous. And Node makes it asynchronous. We by offloading to the system kernel. So I hope you can understand this. Now, since we understand this, right? Since you understand the concept of event loops and what is asynchronous, let me teach you how to handle asynchronicity. First before that, let me give you an example of asynchronicity. Now when you try to print this, right, what will happen is it will print first task, second task, next task is running. So it is running in an order, but I can make it asynchronous. How do I make something asynchronous? I can offload and non-block. So the most basic thing is, we'll say, set timeout. So what does set timeout do? It will put something on hold. That's it. And you can put it on hold for how many ever milliseconds you want. I'm going to put it on hold for 2 milliseconds or 2000 milliseconds or 2 seconds. So if I run it right, it prints first task finished, next task running, and then second task finished. It can run the next task without finishing the second task. Then it can finish the second task at a later point of time. So you understand this, right? But now this code is not throwing out any error because it is a normal code. If let me say something like this, right? You can see, it is actually not thread safe. Set timeout. Let me say. You can see after every 2 seconds, it is going to run this task again and again. Of a time interval of 2 seconds, it is going to do this task. And again, even this is a loop. You have to end this loop. I told you, to end a loop or to end a server, you have to press Control C. So these are, small examples of that. Let me also show you how you can use async, read and write. But before that, when you do this, we have to worry about promise also. There is something called promise. So what is a promise? Now this set timeout, I can keep it inside a promise, or I can resolve it inside a promise. Let me const promise is equal to new promise. you know Promise is an object. Okay, I am creating a promise object using the new keyword. Whenever you create an instance of an object or a class, you call it, you use the keyword new. Okay, so what is going to happen? I'm saying new, and this creates an instance of an object. So inside this promise, I can either resolve or reject. So let me try resolve and reject, both of them. Okay. So a promise takes resolve and reject. You can already see, even if I did not do this, it would take, the promise will take resolve and reject. And what is this going to do? Now we saw this was put on hold, right? Now since this is a console.log, some print function, it is working properly. But if it was a complicated logic, something that might throw error, then the thing I put on hold for timeout or interval is actually going to throw out an error at a later point of time. So that will cause the whole application to crash. If you don't want something like that to happen, right, what you do is, when you do something asynchronous, you promise you promise to the JavaScript program that it will return some data, it will get resolved. Or you promise to the JavaScript program that if some error happens, you will write a reject code, reject logic that will run and mitigate that error, or that will run and not let the application crash. So right now I'm saying, let us say, I'll show you the two types. I'll say, uh, you can have anything, okay, true or false. I'll say true. And if true or false, if true or false is true, then this will run. Else, this will run. So what am I actually doing is resolve. We can say something like file loaded. Will reject file not found. So what we are actually going to do is, we'll call the promise using then and catch. There is also something, instead of promise is one way to handle asynchronicity. I'll also teach you another way, okay? I'll teach you that inside, when we are building project, there is also another way, using await, try and catch, instead of using then and catch. Let me type the code, okay? Let me write it, and I'll explain it later. Promise dot then the promise dot catch. So then, meaning, if it is resolved, if everything goes according to plan, what I will do, I'll get some value, right? What I will do to that value, I'll say console.log, print the value. If some error happens, I will get some error message. I will print that error message. So let us run and see what this is going to show. You can see, right? Even though this is happening before next task running, it is being printed after. I am not setting it some time to do later. It is a promise. It is going to run after some time naturally. The promise can be resolved or can be rejected. Okay, I'll say false here. If I say false, right, It is going to say file not found. If it was true, it was file loaded. Both of them are coming at the end. How are they doing this? Now, the value I'm sending for reject is different from the value I'm sending for resolve. If resolved, I am saying do this logic. And if it is rejected, do this logic. And I am calling that promise. If I don't call this promise right, then it won't happen. Only after I call this promise, it will do either the then or the catch. The then and catch both cannot run at the same time. Only either of them can happen. It can either be resolved or it can either be rejected. It cannot be resolved and rejected at the same time. That is impossible. Okay. So this is one way to handle asynchronicity. Whatever functions that are going to be asynchronous, you can use it inside this promise and say if the data is present, now I will teach you the actual functions which will be using the read file. So this is one of the functions which you can use with async patterns. We saw how to use read file sync and write file sync, right? They happened naturally. You don't have to do anything. If I used read file sync in between this console.log and this console.log, right? What will happen is it will print first task finished, then it will print whatever it is reading, then only it will print next task running. It won't print whatever is in between at the end. But right now, what I'm going to do is I'm going to be using read file sync to read this file. Let us do it. How do you do it? You first import. What do you import? You import the file systems module. FS. Alright. And I am going to read the testing dot txt. I want to read it in UTF read. I'm storing it inside text. If not text. So this is what I'm doing. Alright. Now what is going to happen? This is the promise that you can say this file load promise. Give it some name. Let me save this. Let me run it. So you can see it is already throwing out an error. It is printing first task finished, next task running, but the in between task, this thing is not running. It has printed the error data. What is the error data? It is actually printing is see type string UTF-8 new promise. See the argument receive. Maybe call back. It is actually still throwing out some error. Not on the type of this expression. The CP argument. What is the CP argument? The CP argument of type is throwing out some error. How do I find out? Hmm, forget about this. Let me teach you about await and async later. Or maybe we can directly print it. When it is rejected, it gets this value. Right? Anonymous function. Function will say receives a string. If on remove the new promise consider as a promise. Okay. I forgot. I'm using promise here. Uh, we don't have to do any of this. Right. Now this is already an async function. Okay. So what happens is it is already going to return a promise. You can notice still giving me errors. Let me try to read it without you. See, undefined. Why is it undefined? It is throwing out all these errors because just a second, guys. Give me a second. Okay. You know, I think we can error handle here. Okay. Let us say throw error. That is why we are getting. So now you can see actually it would have worked in the other ways too. I had spelling mistake in the folder name. Alright, don't do spelling mistakes. You can do it this way also. You know what? Read file is already going to return a promise. You can error handle it inside the argument itself. That is why it is an async function by itself. You don't have to use promise. You have to use promise when there is something that is not asynchronous which you are trying to do asynchronous. Now I also used another syntax. Did you see the await and async? We'll look at that more in depth when we actually start building the application. Okay, so right now we have looked at uh, event loops and the async patterns. We looked at promise, the resolve and reject, right? We'll also look at another technique when we use then and catch, right? The if it got resolved, it went to then. If it got rejected, it went to catch. When will it get rejected? When an error happens that you are expecting. Okay, and when you catch the catch block will catch the error you are expecting. But if there was an error that you are not even expecting, there is a block even for that. That is called finally. Okay, there is something called then. No, I'll say it like this. Let me say file load that then this is actually not something. I'll say catch and there is something called finally. So then will run when everything is successful. Catch will run when you are expecting an error and that error has been thrown. Finally will run when there is an error that you did not even account for has occurred. You have to write the logic for all of them inside like this. You have to create an anonymous function, take in arguments if you have arguments, and write the logic. What will happen when it is successful? What will happen when there's an error? What will happen when there's an error that you are not even expecting? So this is how you write then catch finally. But try and catch finally are a little bit different. We'll talk about that later, okay? But I'll write it here now. So you saw how read file worked, right? You did not even have to open a promise. You can directly do them because the form they are returning the data are already promised, resolve and reject. You can error handle them inside the argument itself since it is already asynchronous. If I wanted to use read file sync, which is synchronous, I would have said read file sync. I hope you guys are understanding everything until now. So this is printing all the data here. And if you look at it closely, right, it is printing it at the end and not at the beginning. Meaning it is first printing, first task finished, next task running, and then new data in the text file. This data, new data in the text file. It comes after, even though this code is in between first task finished and next task running, it is only running after both these things are being printed because read file sync by default is asynchronous and returns a promise. So this is how you handle async patterns. Okay, now I don't want to start the concept of streams. Okay, but I'll teach you what streams are and or maybe even we'll finish streams now. The thing about streams, okay, we are reading this data right now. We are reading this file, testing.text, and storing it inside the variable file load promise, right? And I am printing it here. Print the result. That is what it is being printed here. The thing is, you can only store so much information inside a single variable. I told you every time in the beginning of the course, every time you create a variable, a set amount of memory space is allocated to this variable. Now, there is a limit to how much data you can store inside this variable. So, if you have to store data that is larger than that limit, what do you do? Now, that is a very common problem that existed in the beginning of the internet. Okay. Like the data is larger than the storage available. So, what they did was they streamed information, streamed data. Now, the best example would be YouTube. Okay. When you are watching videos inside the YouTube, right? You are actually watching data video, okay, but that video is actually stored inside the server of YouTube. And when you think about it, video data is actually larger than some text. If you create a text file, it will be some kb by kilobytes. But if you take a video, right, sometimes depending on the length of the video, it will even reach hundreds of gigabytes depending on the clarity and the video. So how are you able to store that much amount of data and transfer that much amount of data if the variable is not big enough? you know the variable is not actually big enough. There are datas that we handle that cannot be stored inside a single variable. So those kind of datas will be streamed. What is streamed? You take a big data, break it into smaller buffers. You must have heard about the word buffer. And even here, all data is actually buffer. Okay. If I remove this UTF-8, you will see that word. What will you see? You will see buffers. The buffer will have this much amount of bytes. Each buffer will have some amount of bytes. Okay. And since the text file has not crossed that amount, right, it is there in a single buffer. But a video file which is very large has to be broken down into different buffers and streamed into the pipeline. When you watch YouTube, right, the whole video is not actually given to you. The video is broken down into multiple parts. Okay. If you are watching YouTube, you must have seen this thing. See, if you watch the play loading animation, you will see a red color line moving and a gray color line moving behind it. The gray color line is the buffer, meaning if you go anywhere outside the buffer rate, the data has not yet been loaded, but you can smoothly jump anywhere inside the buffer because the data has already been streamed inside your variable data. So that is how you break big data into smaller chunks. Now, what I'll do is we'll do something. We'll make it sync. Okay. If I make it sync, you will see something. Now, since I made it sync, right, it is not going to print it at the end. It is going to print it at the beginning itself. Like here it is printing first task, next task, and then buffer, right? For simplicity, I'll remove this. But right now, it will print first task, buffer, and then next task running. because right now I'm using sync. Before I was using async, so it was put on await and run later. So regarding this, we will try to send it inside. I'll create a server. Okay, request and response, and the response I'll be sending is I don't have to print it here. We'll also listen to it. Dot listen. Let us listen on 5,000. So what is happening here is I am reading some data, and the data is being printed inside the local host 5,000. You can see the text file we have been creating is now being displayed here. I am reading it and sending it as a response. The response comes as normal text. Now look very carefully at the header. Okay. The header will have something called transfer encoding. It is right now chunked. I don't know why it is chunked. It is automatically chunked, I guess. We have already, I think, crossed the limit of the content length. You will have something called the content length. The content length must not cross a certain type. You can see here, right? These are all the chunks that the file has been broken down, and the data is being given like this. So you can build a response like this. You can actually do that using streams methods. There is also another method called create read stream. Okay, we'll work with this method in the next session. Okay, we'll actually end the class here. The time is already up. If you guys have any doubts, you can ask me in the WhatsApp group. You guys are actually very silent throughout the session. I hope you guys are all practicing what I'm teaching. Looking at the code is not going to help you become a programmer. Even today you saw me, right? I made a spelling mistake and was struggling what to do with it. The more you program, the more errors you will face. The more errors you face, the better programmer you will become. Learning programming won't, you know, make you write code 100% correct every time. You'll always make errors. You'll only learn how to become a good programmer once you learn how to mitigate and debug errors. Okay. So I hope you practice all of the things I'm teaching you guys. Anyways, guys, we'll end the session here today. We'll meet in the next session. Thank you. You can leave the class right now.